Okay, so section 1.3, guys. This is what section 1.3 is about. And not all the information that I put in this handout is required. I'll just tell you exactly what you need to focus on. How to design a statistical study and how to distinguish between an observational study and an experiment. How to collect data by using a survey or a simulation. How to design an experiment. For example, how to design an experiment where this is not required. How to create a sample using random sample, simple random sample, stratified sample, cluster sample, and systematic sample, and how to identify a biased sample. Okay, so let's begin here. How to design a study. We're not going to be designing a statistical study, but I thought it's worth, just noting how to do such a thing. So anytime, just you want to do a statistical study, guys, you have to identify the variable of interest. What is it? What's the focus of your study? Develop a plan for collecting data, and it will be nice, just if the plan is based not on a biased sample, but a real random sample. Collect the data, then describe the data using descriptive statistics, and then at the very end, interpret the data, make conclusion out of the data, and identify any possible errors. In any data that you collect, guys, there are going to be errors because you're collecting a data you're using a sample, you're not using the entire population. The only way to be almost 100% accurate with your inference is if you interview or if you collect the entire population, which is not possible. This year is the census year. Every 10 years, we survey the entire population of the United States. This is a survey of the entire population. This is where the data, the errors, just will be very, very small. But the thing is, even with the census, do you think we'll be able to capture the entire population of the entire United States? The answer is no. They're going to miss still a lot of areas, a lot of people. There are a lot of people who are not going to respond to the census request, to fill out the form. Okay. How do we collect data? Let me show you the methods of collecting data here. Observing. This is the first way to collect data here. Observational study. You sit down, observe, and take notes. A researcher observes and measures characteristics of interest of part of a population. Here is an example. Researchers observed and recorded the mouthing behavior of a non-food objects of children up to 3 years old. So they watch their children, how do they use non-food objects in their mouth, and then take notes. This is one way to collect data. The most famous one is the second one, which is the experiment. You do an experiment. A treatment is applied to part of the population. Responses are observed. I'll tell you how the experiment, works. I'm going to give you, in general, this is how they do an experiment. Let's say a pharmaceutical company wants to test a new medication that lowers cholesterol, for example. They'll bring 2 groups of people. One group will get the medicine, and the other group will get, a water pill, placebo, nothing. And then they'll compare, the 2 groups after they administer the medicine on one group for a while, and then they will compare the results and make a conclusion whether the medicine is effective or not. So it does involve 2 groups, guys, always. One group gets nothing, and the other group gets the treatment. Here is another example here. An experiment was performed in which diabetics took cinnamon extract daily while a control group took none. The group that doesn't take any medication is called the control group, and the group that takes the medication is called the treatment group. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease, while the control group experienced no change. So this is what an experiment is. Number 3, survey. Survey, just like a form, guys, and you fill out. That's what a survey means. So let me show you here. It's an investigation of one or more characteristics of a population commonly done by interview, internet, phone, or mail. Here's an example of a survey. A survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. So you just give him a survey and ask him to answer some questions. The last one is number 4, is simulation. Sometimes it's not possible to do an experiment for real, a live experiment, so you have to do a simulation. Uses a mathematical or physical model to reproduce the condition of a situation or process. Often involves the use of computers. When you do simulations, you mainly probably use computers. Here is an example. Automobile manufacturers use simulations with dummies to study the effects of crashes on humans. They're not gonna put real humans in a car, you know, just and have them go and get into a car accident or crash into something just to see if what they develop works or not. That doesn't happen. They use dummies, or they use simulations. They use computer software. So this is an example of a simulation. What we're gonna do now, guys, I'm gonna go through those 4 examples, and you're gonna tell me whether each one falls under one of the 4 categories. So let me just list them for you. So we have observational study, we have experiment, we have survey, and we have simulation. Okay, I need your help now. I'm gonna read the example and you tell me what category would that be. The first one, a study of the effect of change in flight patterns on the number of airplane accidents. What would that be? One of the 4, guys.
Simulation.
Simulation, yes. 100%. You cannot do that experiment for real and have 2 planes, you know, just collide, you know, in the air just to see what happens. A study of the effect of eating oatmeal on lowering blood pressure. What do you guys think?
Experiment.
Experiment. Yes. Very good, guys. A study of how 4th grade students solve a puzzle.
Observational.
Observational. You observe them. And don't assume the 4th one is going to be a survey. I might trick you and give you something like that and make 2 simulations. So it could be, but probably it is a survey. A study of US residents' approval rating of the US president.
Survey.
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 Yep. Very good. Okay. Key elements of experimental design. This is, guys, optional. It's not required, and you will not see any problems in the homework that reflects on that. But I just have to tell you guys something. When they do an experiment, they bring 2 groups. One group get an actual treatment, another group gets placebo, water pill. And usually they don't tell the group that is getting water pill nothing, that they're getting nothing. They'll give them the impression they're getting something also, to see if the psychology plays a role also in this. So if you like to read this later, that's fine. I'm just gonna move on. These are the key ingredients of an experiment. But since we're not constructing such an experiment in this class, so I'm just gonna leave them out. It's important to understand what the word randomization is, which we're gonna come into this soon. It's a process of randomly assigning subjects to different treatment. Random means, guys, everyone get the same chance to be selected in an experiment. So that's what random. And to do good statistics, any sample that you select, it has to be a random sample. If it is not a random sample, the study is not reliable, the results are not reliable. So it's very, very critical that the sample must be a random sample. We'll talk about that now, actually. So, okay. Randomized design is when subjects are assigned to different treatment groups through random selection. Anything that is random, guys, is good. Anything that is random is good. Sample size. What is the sample size? Is the number of subjects in the study. So if I pick 5 students, that means my sample size is 5, and that's what a sample size is. Okay, I'm gonna skip this. As I told you, no worry about this part. Now we're gonna get to the part that's really covered in this section. Sampling techniques. That is required, guys. And you're gonna have lots of questions in section 1.3 on this. Random sample. Every member of the population has an equal chance of being selected. Now I have a group of, I don't know how many of you here, 25 students. If I want to select 4 students at random, guys, what would be the best way to do it? You can type it in. You can talk to me. What do you think, guys, would be the best way to select a group of 4 students randomly from your group? Any ideas? Put the names on pieces of paper, names in a hat. Yes, yes, I agree. I agree. And I have to pick the names without looking. You agree with that, guys? Yeah, the best way, guys, put the names in a basket and randomly just pick 4 names. That is random sample. That is a very good sampling techniques. Now, let's say I have, it turns out, just 4 names are female, that's okay. Even if I have male students in the class, as long as you do it in a random way, guys, you're safe. You have a good statistics here. Now, let me tell you what a simple random sample is. A simple random sample, every possible sample of the same size has the same chance of being selected. I'm gonna tell you what's not a simple random sample so you can understand what a simple random sample is. Let's say I have you guys seated this way. 4 rows, 6 students each. Watch this. Okay. Watch here. So this is the first column. This is the second column. This is the third column, 4th, 5th, and this is the 6th one. So I have 24 students in the class. They're sitting 4 rows, 6 columns. I want to select 4 students. Here's what a student suggested. He said, you can write down the names of the 6 columns, column 1, column 2, column 3, column 4, column 5, column 6, and select 1 column. And once you select 1 column, all students in the column will be the members of the sample. Guys, this is not a simple random sample, because a simple random sample, it says every possible sample of the same size has the same chance of being selected. Why couldn't this be a simple random sample? Would someone be able to explain that? So you can understand what a simple random sample. Although we put the C1, C2, C3, C4, C5, C6 in a basket, and I just pick 1 column name at random, and I said these are gonna be the members of my sample. So what's wrong with picking this? What's wrong with picking the column? Why this is not simple? random sample?
Because some columns don't have the chance of being selected.
Oh, you mean, okay, let me tell you what the problem is. This student right here, and this student, and probably this, and that will never be together because I'm doing it this way. I'm not going that way. I'm not collecting. So these five, and then this is a sample, 1, 2, 3, 4, for example. These 4 students can never be together in a sample, and that is a violation of the definition of a simple random sample. So the best way, guys, to do a simple random sample, put the names in a basket and select 4 names. That would be a simple random sample. Okay, so now we understand what a simple random sample is. I'm gonna show you another way, guys, to pick random samples using random numbers. But now we have technology, even your calculator can pick samples. Let's say you wanna ask your calculator to pick 4 students at random from a sample that has 30 students. There is a program on the calculator. Just tell the calculator, I have 1 through 30, and pick 4 numbers between 1 and 30, and it will give you 4 numbers. That would be a random sample. But here is another way, guys. You might come across this to pick random samples. I'm gonna show you. This is not required. I will not be asking you in a test, just to pick samples this way, but you should know about it. Let's say I have 731 students in a class, and you wish to form a sample of 80 students to answer some survey questions. We need to pick how many? 8 students. Let me show you how we can do that. We can number the students from 1 to 731. But since I have 3-digit numbers, guys, number 1 should be labeled like this, 001. And then 002, and then 003, all the way to 731. And let me show you how a statistician used to use random numbers when technology was not available to select random samples. This is the table right there. It's a bigger table, guys, but I'm just took a screenshot, just of a part of it. Let me show you how I can pick 8 students at random. You put your fingers somewhere and start somewhere. Here it says, well, let's start here. So I put the arrow right here. I'm gonna start. You can start anywhere you want, guys. So no 2 students will get the same sample. You all get different samples, unless if I instruct you to start, all of you start right here. So we start right here, and we start reading 3-digit at the time. If you read 719, so this is the first digit, the first number. Is 719 a part of the group? Yeah, it goes as high as 731. So that will be the first member of the sample. Now let's read the next 3 digits. 662, that's the second one. 738. Well, there is no 738 in my list. It goes as high as 731, so that wouldn't count. 650. We're here, we're done here. Now, 3 digits, 004, guys, that's another one. So if you were thinking that you will not get single digits, yes, you do. It's 004. Next one, 053. How many more do I need? 3 more. 589. You just read them horizontally. 403. And so on and so forth. So this is how you can use a table to collect a sample. But now we have sophisticated technology. Even calculators can do random samples for us. So this table is not used very frequently. All right.
I have a question.
Yes.
So with that last thing that you were doing with the numbers, that's how you were trying to get a random sample?
Exactly.
Okay.
And the starting point, it could be anywhere you want. You can just put your finger anywhere and start from there and pick 3 digits. The only requirement is the 3-digit that you pick has to be between 1 and 731. If they're not between 1 and 731, then you don't consider them and keep going.
Okay.
I also have a
Other
question.
sampling techniques, guys. Let me show you And please pay attention to those, because you'll be working mainly with those things in section 1.3. Stratified sample. This is called a stratified sample. Here's how this works. You divide the population into groups, and then you go and get members from each group and put them together to make your sample. And I'm going to give you to collect a stratified sample for the number of people who live in Westridge County households. You could divide the households into socioeconomic levels: low income group, middle income group, and high income group, and go and select members from each group and put them together to make your sample. That sounds like very fair. You represented all socioeconomic levels, you know, in the community. You didn't leave anyone out. So this is one way to do sampling, and this is called the stratified sample. So in other words, guys, stratified samples divide your population into groups, subgroups, which is called the stratas, and then pick from each group and put them together to make your sample. This is what stratified. Cluster. The second one is called the cluster sample. This is another sampling technique that statisticians use. Divide the population into groups. For example, here I'm showing you we're dividing the Westridge County into zones: zone 1, zone 2, zone 3, zone 4, zone 5. And then you go and pick all the members in one or more zones and make them your sample. That would be a cluster sample. Another example, guys, let's say the city of Dearborn, divided into zip codes. Okay, let's say this is the city of Dearborn. 48124. I don't know what all the zip codes are. Okay, I'll just put those. Okay, we divide the city into zip codes, and then I'll go and pick one zip code at random. Let's say put 48127. And I said everybody in this zip code is going to be a part of the sample. So this is what a cluster is. Now, probably you'll tell me a stratified sample would be better because you're representing all sectors of the population. No, I mean a stratified sample, you might argue that this is a better way of sampling. It depends on the situation. If all those zones share the same characteristics, guys, and have lots of things in common, it doesn't matter, you know, just if you take from each zone. If one zone can represent all others, then I think that would work as well. So there are times where statisticians use stratified, and other times where statisticians use a cluster sample. So it does work either way. Systematic sample. This is an easy one. Let me show you what a systematic sample is. Let's say, guys, as you sign in today, I wanted to collect a sample of 5 students. Here's one way I could have done it. I'll sign in at 10 o'clock. The first students who show up at 10, I'll tell that students that you're gonna be a member of the sample. And then I'll wait for every 30 students who sign in and tell every 30 students who sign in after 10 o'clock that you're gonna be a member of my sample. So you create a system every 4th, every 5th, or let's say you stand, you know, just by the entrance of a mall and you wanna collect, you know, just a sample of 15 people and interview them. You can say, I'm gonna interview every 10th person who walk into the mall. So you create an interval for yourself and you use it to create the systematic sample. So you choose a starting value at random, then choose every kth member of the population. Kth could be 2nd, 3rd, 4th, etc. Here is an example, guys. We picked this person to start with right here, and then we picked every 3rd one. Watch, guys. 1, 2, 3. 1, 2, 3. 1, 2, the 3rd. 1, 2, the 3rd, and so on and so forth. So this is what systematic sample. So this is the 3rd way of selecting a sample. The last one, guys, and this is statisticians should avoid. This is a biased one. Convenience sample. Choose only members of the population that are easy to get. Often leads to biased studies. This is not a recommended sample. I'll give you an example. Here's an example that I always give to students. Let's say I wanted to survey students on the distance they commute from home to school. And I decided to do it in the winter. It's a day, a lot of snow. Most students did not show up to class, and only 4 or 5 students showed up to class. So I decided, I told those 4 or 5 students, you're gonna be my sample and I'm gonna do the survey with you. This is convenience and this is a biased sample. Can you tell me why? Remember, only 5 students were present in the class, and I decided to make those 5 students my sample. And the rest of the students did not show up because of bad weather. So why do you think this is convenience? What's wrong with it? It's biased. Any comments?
Is it because you're only choosing the students that were able to show up to class?
Exactly. What about the other 25?
Because they weren't able to.
Yes, yes, and that's wrong. And that's we shouldn't. I mean, this is one way to sample, but and then I told you the survey is on the distance that students commute. Do you know, guys, what the results of the survey are going to reveal? Those students are probably they live very close to the college. That's why they showed up. So I'm going to end up making a prediction that the distance that students commute to school is not that much miles, you know, based on those 5 students, which is, could be a wrong prediction because the majority of students did not show up to class. I'll tell you another convenience sample example. If you send a survey via email, only people who check their email probably will respond, you know, to the survey. This is biased also. So you guys, when you do a survey, you should use different methods of contacting people, not only emails. If you think that you use email, probably other people don't. Or if you call people, most people don't answer their phone, and most people even don't have a landline phone anymore. So this is also can lead to bias in sampling. So probably from now on, you should start questioning anything that you see, whether it's based, you know, on a random sample or a biased sample. Okay, let's do this exercise together. So we have the sampling techniques, and we're gonna match each example with the sampling technique. Let me list them again, so just so you can see what we're doing right here. We have a simple random sample. We have stratified. We have a cluster. We have systematic. And we have convenience. Okay, let's see what you guys think of those examples. Examples. You are doing a study to determine the opinion of students at your school regarding stem cells research. Identify the sampling technique used. You divide the student population with respect to measures and randomly select and question some students in each measure. So we divide the groups into measures: biology, statistics, chemistry, business, etc. And then we select from each measure. What do you think the sampling technique is called here?
Stratified.
Stratified. The difference between stratified and cluster. Cluster, you divide students into measures, let's say biology, chemistry, etc. And then you go to all students in one measure or 2 measures and pick all of them and put them in the sample. But stratified, you just pick from each one and put them in the sample. Okay, number 2. Let's see what you think of number 2 now. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected.
It says simple random sample.
You got it. Okay, let me say something about this. This example I used last semester, and some students were tempted to tell me systematic because we're assigning numbers, and then, but then I told the students, where is the system here? Are we picking every third or every fourth or every fifth? They said no. Then they said, no, these are random numbers. Once you see the word random, guys, it's a simple random sample. Okay, let's see. And I guess that's the end of chapter 1. Okay, I have a summary here, guys. You can use it if you want to just summarize. It's in your handout. This is a summary of the lesson. So this is what you need to know in chapter 1, and that would be required, you know, just for the test. You need to know what the data, population, sample, parameter, statistics are, difference between descriptive and inferential statistics, quantitative and qualitative data, levels of measurement that we did, guys, already, observational study, survey. Okay. What else? Okay, this you don't have to worry about here. Key elements of the experiment also, that's not required, as I told you. Let me show you what else here. And sampling techniques. This is what we just touched on. The random sample, simple random sample, stratified, cluster, systematic, and I failed to include the convenience sampling technique, but you understand what convenience sampling is. That should take care of chapter 1, and tell you what chapter 2 is about. Chapter 2, guys, is about organizing and summarizing data. So the first way to organize data is to organize data in tables, which we call them frequency distribution tables. I'm gonna start with an example. The best way to explain something is just show an example how it works. And then out of the example, guys, you can figure out how to do other frequency distributions tables. So I'm gonna start with number 1. Marsh utility bills and dollars of 30 homeowners are listed below. Construct a frequency distribution and a relative frequency distribution using 6 classes. As you can see, the data now, as it shows right now, it's not very organized. It's a little bit hard to tell, you know, just to make a summary or make a conclusion out of the data. So it's nice to be able to organize this data into a table. Just like your schedule of classes, it's organized in a table. Calendar, this is an organized table. We should be able to organize any data set. Let me ask you, what would be the lowest utility bill here? I think it's 33 probably. That's the lowest. And what would be the highest? 50. Yeah. So you guys, let me suggest this way to create a table and tell me if you think this is a good way or not. What about if I put 33, 34, all the way to 50 and see how many have 33, how many have 34, how many bills were 35, 36, 37. Would you like this way of organizing the data? And if not, tell me why. I don't think this is a good way to organize data. What's not good about this? What's not good about it, this is going to have a table with 17 or 18 rows. Too many rows. Too many rows. Nobody is going to bother to look at your table. So I'm going to show you a nice, easy way to create a table with a minimum number of rows so that they will appeal, just to the viewer, to the reader, and people would be willing, just to look at it, and get something out of the table. So he says, construct a frequency distribution table using 6 classes. 6 classes means, guys, he wants 6 rows in here. And I'm going to show you how to do it with exactly 6 rows. So we did the minimum one and we did the maximum value. We do the maximum minus the minimum. So these are the steps, and please pay attention to the steps to show you how to construct the table. So that's 50 minus 33, which is 17. Then you divide the 7. So the difference between the lowest value and the largest value is 17. You take this 17 and we need to split it up over 6 rows because he says 6 classes, so you divide 17 by 6. And 17, if you divide it by 6, it's going to be about 2.83. You round this number up always, round it up. So 2.83, it's going to take you up to 3. Even if it turns out to be 2.1, guys, you round up to get the whole number, so which is a 3. And let me show you how to construct the table. This technique, guys, you're going to be using throughout this section to construct tables. Okay. Instead of listing the amounts 33, 34, 35, 36, I'm going to do them in intervals. I'm going to begin with 33. That's the lowest amount, so it makes sense to begin with 33. What was this number that I just came up with? It's a 3. I would like it to add this 3 this way. So plus 3 here. That's going to give me 36 plus 3. Let me see here. I have some. You round up 2.83, you round it to the nearest whole number. So 2.83 goes up to 3, always up to the next whole number. Okay, plus 3, guys, will give me 39. Plus 3 will give me 42. Plus 3 will give me 45. And plus 3 will give me 48. Now, we put this number here, which is 36. What is the number, the whole number, which is right before 36? It's 35. And then, guys, you start adding 3 this way as well. That's 38. That is what? 41. That is 44. That is 47. And here you go. Bingo. We got the 50 that we want. And that is 50. So these are called the classes, intervals. So this table has 6 classes. So this is called a class, guys. This is a first class, second class, third class, fourth class, fifth class, sixth class, and that's in compliance what he said. And when you add this number that you generated right here, you have to add it this way. If you add it that way, guys, you're gonna fall short. You're not gonna end up with 6 classes, so you always add it up vertically. This number that we just generated right here, it's called the class width. So the formula for the class width, it's maximum value minus minimum divided by number of classes. And that's what I did. This is what the class width. In order to construct a table, you need the class width. You begin with the lowest value and start adding this class width here. We got 36. The number that is before 36 is 35. You put it here and then add a 3 again. Now the tally, guys, if you like to use it, fine. If not, it's okay. I need to figure out how many values are there between 33 and 35. Let's do it together. Between 33 and 35, I have 1 inclusive, 2,
3.
3. You can do tally like this, guys, 1, 2, 3. But that's not required, really. Between 36 and 38 inclusive. 1, 2, 3, 4, 5, 6, 6. So you can see how the tally works. If you learned that at school, 1, 2, 3, 4, 5, and that's a 1. 39 and 41. Okay. 1, 2, 3, 4, 5. Is that 5 correct? Or I missed anything? 1, 2, 3, 4, 5. Okay. 4 and 1 across. 42 and 44, guys. Between 42 and 44, inclusive. 44 is included. 43, that's a 3. 4, 5, 6. Okay. 45 to 47. How many are there? 45 to 47. Okay, I got 1, 2, 3. 1, 2, 3, and here 1, 2, 3, 4, 5, 1. And the last one should be the rest. I got 9, 5, 14, and 6, 20, 23. So that should be 7. Let's count them and make sure that we're good here. 7 between 48 and 50. 1, 2, 3, 4, 5, 6. So there must have been, I think this one should have been 6 probably. You guys agree?
The third arrow, I think it's supposed to be 6.
Yeah, you're right. It is 6. Now it's working. Okay. This is what we call a frequency distribution table, guys. This is how it works. You figure out the class width. You start with the lowest value and you add the class width this way. And then you figure out, just this value here, which is the value, which is 1 less than that one. And then you add a 3 that way, and then you construct the table. And the frequency, so what is the definition of a frequency? The frequency, how many times the numbers between 33 and 35 show up or occur in the data set. You just count them. That's what the frequency is. Now, let me tell you what a relative frequency is. Relative frequency is a percent, guys. It's a ratio. So I have a 3 here, but out of how many? How many homeowners do I have? 30. So a relative frequency will be 3 divided by 30, which is 0.1. Here, 6 out of 30. So it's always a relative frequency will be the frequency divided by the total. 6 divided by 30. 6 divided by 30. 3 divided by 30, which is 0.1. 6 divided by 30, which is 0.2. 0.2. 0.2. 0.2. If you add them up, you should get 1, which is 100%. So this is what frequency distribution table is. Any questions, guys? Let's see. Chat, let me see in the chat box. Oh, because we put 30, there are 30 of them. So if you count them, the total here should be 30. If you count the frequencies, sum of the frequencies should be 30. That's a 30 values right there. All right. Okay. Let's do this exercise together. Number 2. A sample of 15 Boy Scouts was selected and their weights in pounds were recorded as follows. Using a class width of 10. So he gives us the class width already, guys. It's 10. Give the upper and lower limits of the 5 classes, starting with the lower limit of 95. Okay, before I do that, this is called the class right here. This number here is called the lower limit of the class, and this is called the upper limit. This is a class number 2. The lower limit is 36 and the upper limit is 38. Class 3, lower limit is 39. So all of those numbers, guys, are called lower limit, and all those numbers are called upper limit. So he wants us to use a class width of 10, and he wants us to start with 95. So if I start with 95, right here, okay. Can you tell me what would be the number next right there? He says use a class width of 105, exactly, because he says use 10, and this is 115, 125, 135. Now, can you guys tell me what the numbers are going to be here? What is this number? It's one number below 105, immediately below 105. So that will be what? 104. And then start adding 10. And here you go. Now the frequency. We need to figure out how many values are there between 95 and 104. I have 97, 100, so that's 2. How many values are there between 105 and 114 inclusive? 1, 2, 3. How many values are between 115 and 124 inclusive? 115 and 124. So that's 1, 2, 3. How many values are there between 125 and 134 inclusive? 125, that's 1, 2, 3, 2. 3 is, sorry. And the rest, 9 and 2, 11, that must be 4. And that should take care of it. That's a frequency distribution table. All right, guys, so that's how to work with the frequency distribution table. Now, the next one. For the data below, construct a relative frequency distribution. So he wants a relative frequency. That should be an easy one. You don't. How would you do it? Can you guys tell me? Should be an easy one. Okay, what do I do to do the relative frequency? He already gave us the frequency table. He just wants the relative frequency.
So would it be 1/3?
We need to figure out, first of all, what? The total. 5 plus 8, 13, plus 12, 25, and 13, 38, it's 49. So what would that be, you guys? 5 divided by what? 49. 8 divided by 49. 12 divided by 49. 13 divided by 49. And 11 divided by 49. You just figure out the total and take each frequency and divide it by the total. That's what a relative frequency is, guys. It's as simple as that. So this is what a frequency distribution table is, and this is how you construct it. When you do your homework in section 2.2, you will be asked to construct a frequency distribution table. Use just what you learned to do that. You will get a table, guys, with the blanks, and then the system will ask you to fill in the blanks, and you just do it exactly how you learned here.
I have a question. Could we go back to the other table really quick?
Yes.
So for this one, the frequency was 30, not because there's 30 numbers in the table, but because the frequency, all
No,
the numbers in the frequency column.
because there are 30 numbers in the table.
Oh,
It's exactly what's in the table. How many items in there?
okay, but isn't there like 15 numbers in this next problem?
Which one?
The second, can you go back down to the second table?
Yeah, the second table there was 15, yes, but we're not doing the second one. Look what we're doing. This is a totally different question. Number 3. He didn't give us the actual data, but he gave us the frequencies. When you add up the frequencies, it should be, that's the total number. And here, if you add up the frequencies, you're right, it's 15, and I have 15 values. He gave us the actual values here. But here, he didn't give me the actual values. But if you add up the frequencies, you knew that he was talking about 49 of them.
Okay, thank you.
Does that make sense?
Yeah.
Okay. Histogram, guys. What is a histogram? Are you familiar with histograms? Do you know what a histogram looks like? A histogram is a bar graph, but the bars are connected. So they touch each other. So I'm going to show you how to construct a histogram. You will not be asked to construct a histogram online, but you will be given probably 4 histograms and be asked to identify which histogram works for the data set. So I'm going to show you how to construct one, very straightforward. So number 4, we're still doing section 2.1, guys. It's kind of a long section here. For the data below, construct a frequency histogram and relative frequency histogram. Okay, you have the frequency distribution table, you have the frequencies, we need to construct the histogram. Let me show you how I would do this. All right. First of all, guys, the highest frequency is 15, so I need to scale this one so I can go as high as 15. Look how I'm gonna do it. I'm gonna do it to 3 each time. It's up to you. 3, 6, 9, 12, and then 15. Okay. The first one, it says it's 6. So look, I'm gonna start somewhere and I'll show you how we're gonna label the horizontal axis in a little bit. Okay, that's the first one. The second one is 4. I just go a little bit above 3. Make sure the size of your column is exactly the same as the previous one. The next one is 11, so it's way a little bit below 12, guys. I'll try to be as consistent as possible. Next one is 15, that's gonna go up to 15. Excel can do this, or StatCrunch in a second. And 8, it's a little bit below 9, right here. This is the weight here. You label that as a weight, and this is the frequency. Okay. Now the question is, how am I gonna label those columns, what each one is? Any ideas, guys? What do you suggest? I'm not gonna put 135 to 139 and then 140. That's gonna make it very crowded and busy, and it's not gonna look nice. Any suggestion, guys? How can we label, you know, those columns? Any ideas? No ideas? Okay, I'm gonna show you how an easy way to label them. If you have your calculator handy, guys, I'd like you to find the middle between 135 and 139. What's the middle value? To find the middle value between 135 and 139, you just add them up and divide by 2. If you do this, it will be 137. And look, just put the center here and make it 137. Now, can a student tell me what the class width here? You read the class width vertically, not horizontally, guys. So what is the class width in here? What's the difference between 135 and 140? The difference between 135 and 140 is 5, not 4. If you go this way, it will be 4, but that's wrong. You have to go that way. So it is 5. Look what you do, guys. Instead of finding the middle of the next class width, just add 5 and it's gonna work. See, I'm adding 5. And if you guys don't believe me here, just do the middle of 155 and 159. It's gonna turn out to be 157. And this is the histogram. Now, one student might ask this question, and I've had this question asked before. They told me, Mr. Bazzi, you did this graph without gaps, although the table shows that there are gaps. And you see there are gaps in the table. We go from 135 to 139, and then we break and we jump from 139 to 140. So there is a jump of 1. So there is a gap of 1. But I'll tell you how Excel does this and how it takes care of the gap so it doesn't show the gap. The difference is 1. If you ask Excel to construct a histogram, this is what Excel is gonna do. It's gonna look at the difference between 139 and 140, which is 1. It's gonna divide the 1 into 2 equal pieces, which is a half. It's gonna give a half to 139, so it will become 139 and a half, and it's gonna deduct from the lower class limit a half, that will become 139 and a half. And this way, you guys, there is no gap anymore. Same thing is gonna happen right here. 144 is gonna become 144 and a half, but this one is, we're gonna deduct a half. So you add to one side and you subtract it from the other side. It's just like you did nothing. It's 144 and a half. And that should take care of the gap. And that's how Excel does it. But you don't have to worry about that. You just do what you did here and connect the graphs. So this is what a histogram is, guys. And just to enforce the definition of the histogram, I have this question for you. What's the difference between a bar chart and a histogram? Can you pick the correct answer, guys? You should be able to tell.
The bars in a bar chart do not touch, while the bars of the histogram do touch.
Exactly. That's what you need to know about histograms. All right, let me tell you what a frequency polygon is. This is another graph, and that's probably it for this section. Okay. A frequency polygon. I'm gonna do it on the histogram that I just did right here and show you what the polygon is. Polygon means many lines connected together. And this is how a frequency polygon works. Watch, guys, look how you construct it. You label the beginning of the first bar and the end of the last bar. Then you label, you pinpoint the center at the top. And look, this is a polygon graph. You start here, then you go from this center to that center, then you go up, then you go here, then you go there, and then you come back to the end right here. This is what we call a polygon graph. So to do it here, I have to do the histogram first. And I have up to 13. So you guys, I'm gonna label this as 2, 4, 6, 8, 10, 12, 14, 16, etc. I'll do it so you can have a feel of how this works. This is height right here. Okay, you don't see this, now you see it. And this is the frequency. And watch, guys. It's 5 for the first one, so halfway between 4 and 6. Then 8. Make sure that they touch. Then 12. Then 13, we go a little bit higher, halfway between 12 and 14. Then 11, between 10 and right here. The midpoint between 50 and 52 halfway is 51, guys. And the class width is this way. You count that way. So 50 to 53 is 3. So 54, 57, 60, and then 63. And here's a polygon graph. Watch. You just label here. And connect one. And then I need to go all the way down. And that's what we call a polygon graph, guys. Again, you will not be asked to construct a polygon graph by hand, but will be asked to recognize a polygon graph on in this section. So you'll be given a data set and asked to recognize which one matches with the data set that you have. One thing also I like to bring to your attention, in some graphs you will see this symbol here. Do you guys know what that means? When you see it, you know, just in a graph. If you open a newspaper and go online, if you want to see a good graph, it has to show, you know, this one. This one, it tells you a warning here that we do not start at 0. So I started like, you know, just at 50 here. And same thing here. I didn't begin, you know, just from 0. I began, you know, just at this number. So this is to alert the reader that we're not starting at 0. So that's very important in statistics to show that. Okay. Any questions about polygon graphs? Okay. Let's see what we have right there. Okay, I'm just gonna do one more thing. Should take a few minutes, and we'll be done with today's lesson. That's an easy one. In section 2.2, guys, you only need to know how to work with stem and leaf plot. Not sure how many of you are familiar with stem and leaf, but it's an easy graph to construct. So a stem and leaf plot. How do you construct a stem and leaf? Stem and leaf is what it says. You break down the graph into two pieces. One is called the stem and one is called the leaf. And I already prepared that for you. The stem is gonna be here. The leaf is gonna be there. Since I have 2-digit numbers, guys, it makes sense for the leaf to be a single digit and the stem to be another single digit. Since we're doing a stem and leaf, so the leaf is gonna be the 1s and the stem is gonna be the 10s. Okay, what are the 10s that I have here? I have 40s, I have 30s, I have 50s. Do I have 60s? So 40s, 50s, 60s, look, and I have 30s. You put a 3 here, you put a 4, you put a 5, and do we have any 60s? No, it's all between 30 and 50. And look how you construct the stem and leaf plot, watch. 44, you just put another 4 here. You already put the 10, so just put the 1s here, 44. 38, right here. 41, 50, 0. 36, 6. 36 again, 6. 43, should I have picked a shorter one? That's a lot of data there. 2. 49, 8. 35, 40. I hope I have enough room to finish this. 7, 41, 43, 50, another 0, 45, 45, 39, 38, 50, 41, 47, okay, 36, 35, 40. Oops, I don't have room. I have 33. Then I need 3, 8, 2, 3, 8, 42, 43, 48. So 2 and 3 and 8. Let's assume they're there. This is what we call a stem and leaf plot. But for a reader, guys, if someone looks at this graph, they're not going to make any sense of it. So what would you provide a reader to understand, you know, just this graph?
A key.
A key. Very good. And the key, look what you tell the reader. You tell the reader, if you see a 3 and an 8 together, please know that that means the number 38, and that's what your key. You can put a different key. You can put 44, 44. Now, does this graph make the data easy to comprehend and read? Yes. Can you guys tell me what would be the most popular, you know, just utility bill, the most common utility bill? Do you guys agree with me that it is in the 40s? Because I see most of the data is in the 40s. And I want to show you something, guys. If you rotate this page, you know, 90 degrees this way, it's going to look like a histogram. Watch if it is like that. So it's very much, you know, just like a histogram. My question to you before we wrap this up, what about if we have data sets like this? How would you do a stem and leaf plot with 3 digits?
So the stem would be hundreds, and then the leaf with ones.
Exactly. The stems will be the tens and the hundred. No, the leaf is always one single digit. So the stem will be the tens and the hundreds, and the leaf will be the single digit. So I have 10 and 100, 20 and 100. So I'll just put 1, 1 here. I'll put 1, 2, and watch, guys. 1, 2, 3, 1, 1, 7, 1, 2, 2, 1, 2, 5, 1, 1, 8, and 9. And make sure to tell the reader that I have a key for you. 117 means 117. All right. And last thing, guys, is
I just have a little question.
well, yes, go ahead.
You said the leaf is always single digit?
The leaf is a single digit, yes.
Okay.
And the stem is whatever. I'm going to show you this example I put on the test last semester, and many students did not give the correct answer, although it was a very, very easy question because students did not read the whole thing. Watch. I had this. I gave a student something like that. I'm just going to make this up just to give you an idea. Okay. I gave students something like that online, and then I asked him, what is the actual data set? One of the answer was this, guys. And most of the students have picked this answer. And that was not correct. Do you guys know why this is not correct?
Because they're supposed to be decimals.
There's supposed to be a decimal there. I told them. Most of the students did not look at the key. The key is 1.5 means 1.5. It doesn't mean 15. So there was actually another one, guys, with the correct, it was like the last part. But students look at this, oh, it matched 1.5, 1.6, 1.7. What I'm trying to tell you here, make sure to look at the key very carefully. It's important.
So on the exam, you're gonna give us a key. We don't have to make the key ourselves.
No, you don't make the key. I'll tell you what the key is. Unless if you're constructing the graph yourself, then you produce the key. But when they give you a stem and leaf plot, they have to give you the key. The last part, guys, I'd like you to look at this graph here and tell you what's misleading about this graph. Someone is making the claim that the volume of the sales has doubled. And so this person is saying, you know, the volume of the sales has doubled. So instead of having a length and a width of 2 by 2, he make it 4 by 4 to convey his message. What is wrong with this? Does this show that the volume of the sales has doubled from this to that? What does it look to you guys? Does it look like here that the volume has doubled, or it's a lot more than double?
It's A. Is it A?
A lot more than doubles.
It's more than double. Look, I have a 4 here, but here I have 16. But the person is trying to be smart. He said, well, doubled means the length has doubled, the width has doubled. But if you double the length and you double the width, look what happens to the entire area. Not only it doubles, it will be multiplied by 4. This is how people tweak statistics, guys, to convey their message. So actually, the length of a side has doubled, but the area has been multiplied by 4. That's wrong. Yeah, that shouldn't be the case. So this is a misleading statistics. But when you tell the person, well, you did the wrong math, they tell you, no, I said doubled and I doubled everything. Well, you can't just double everything. If this person were to really convey, you know, just a true message, you know what he could have done? He could have done this. That is double of 4. That's not a double. But this is how you try, you know, just to mislead people by showing messages like that. Okay, I will stop here, guys. We will continue tomorrow with the section 2.3, 4, and then probably we'll do 2.5 next time. Before you sign off, I would like you guys to make sure that you put your name in the chat room so I can keep track of attendance.